Good day to all. Under the stewardship of Encephalon, Holy Angel University's Technology Business Incubator, and in collaboration with our industry partners, Techno Philippines Innovation Corporation and Edge Systems Engineering Services, we present to you our research project proposal entitled Integration of Machine Learning Inference on Home Energy Storage System to deliver long-term optimized self-consumption with low probability of power loss. To begin with, we would like to present some interesting perspectives that are relevant to our research problem. Known to everyone, Philippines has the highest electricity rate in Southeast Asia at $0.19 per kilowatt hour. We are also the second most expensive in Asia, just next to Japan, a developed country. We are in the top 20 globally. As of January 2020, there are about 1,944,072 households within the coverage areas of electric cooperatives across the country still without access to electricity, of which most are in remote and unviable off-grid locations. Only 32% of our energy mix comes from renewable energy, of which only 1% comes from solar, despite the fact that it is more sun in the Philippines. The residential sector accounts for 18.95 terawatt hours, which is 24.2% of the total, and is estimated to grow by 3.33% a year in the face of an estimated 1.7% increase in the number of households reaching 35.1 million by 2040. With this, the goal of 100% of electrification presents new challenges to existing capacities of our energy resources. Particularly in the Philippines, PV self-consumption energy systems for home have never been affordable, reliable, and profitable. We underscore the anomaly between the performance and financial aspect. Collectively, the techno-economic model of existing solutions in the local market today has led to very low bankability of residential PV energy systems. Bankability, or the likelihood that any technology will be funded, relates to its quality, reliability, and ability to deliver long-term profitability. This brings us to the research problem or industry challenge. The bankability barrier, coupled with much weaker purchasing power of most Filipinos in the face of lacking regulatory and financial support, is discerned as a key challenge towards commodification of PV energy systems to become regular household appliances. The AI integrated energy management system we are going to develop is a discrete and scalable module. It can be configured to fit various configurations of a home energy storage system. We will not develop our own inverters and chargers. All we need is accessible and controllable interfaces with these devices. This can be provided by most OEM producers. On the other hand, we plan to assemble battery packs locally as it is cheaper to import battery cells than the whole battery pack due to additional safety measures being imposed. Integrated into EMS algorithm is a routine to collect data such as but not limited to the following: generation data, consumption data, and state of charge. This study, as well as the outcome, will bring a number of economic and societal benefits. What this research project aims to create is a market-based solution that does not rely on government subsidies or incentives, but directly engages the consumers in self-generating their own electricity. HESS promotes grid independence as another way to address energy poverty and imminent energy crisis with rapidly growing population in the rural areas. Electric cooperatives can employ HESS as much better alternative technology in the electrification of off-grid areas and resettlements. It can address multidimensional energy poverty in the rural areas since it can provide universal access to modern energy services as opposed to mere lighting provided by what the electric cooperatives are using today. With a system like HESS, electric cooperatives are able to extend grid-based energy services to off-grid locations. It also stimulates innovation in the finance sector to fund renewable energy products at the level of households. These are several ways by which a financial institution could mitigate the risk, regardless of the financing scheme. A value proposition that matches electricity savings per month with the principal and interest payments is possible with HESS. Aside from being a household power system, HESS can have other useful applications in the communities and small businesses. It can be used as a mobile power system during disasters, emergencies, and rescue operations, most especially in the event of power outage and grid failure, as power source for evacuation centers and daycare centers in the remote communities, as off-grid power source for radio beacons, repeaters, or community cellular networks, or CCNs, as low-cost alternative to grid electricity for small businesses and mobile vendors. Considering all the socio-economic benefits, it can also help accelerate the transition to clean energy, thus bringing significant environmental impacts in the long run. One unit of HESS can yield potentially 882 kilowatt-hour per year, which is equal to 0.624 metric tons of carbon dioxide. Similarly, it is equivalent to the following: 312 kilograms of coal burned, 1.4 barrels of oil consumed, 232 liters of diesel, 79,530 number of smartphones charged, and carbon sequestered by 10.33 seedlings grown for 10 years.